In the previous chapter, we discussed about variables and where we can use variables. And in this chapter, we will basically do some exercises. We will have an hands-on for both literals and variables and write some programs to understand this concept. Please ensure you complete the hands-on. All right, so now let's go ahead and write a program to understand different literals that we have, and also look at writing a simple program for simple calculator where we also understand how to use variables. Okay, so with this, let me first go and take you through the literals demo program. So in our Java Labs folder, I have created literals and variables as a folder. So this is a separate folder for this particular exercise. So you could also follow the same steps. And I have created the same package, com, then OLC, JFSD, JESS. And here I have two files for this particular hands-on. One is literals demo. So first let us understand what is there in the literals demo exercise. So let's go and open this particular file here. So this looks like a lengthy program, but don't worry, it's a very simple program just to give you an understanding of what are the different literals that we can have, and whatever we have covered in the theory, we are just trying to understand them and write a program so that we can use those literals in our program. All right, so now with this, I don't need to really walk through the main method and other structure, etc. So by now you should be clear. And integer literals is pretty simple. So here I have given a simple demo where you could also use this underscore, which can be useful especially for representing a huge or a lengthy numeric literal or integer literal, right? Then we have decimal, binary, and in order to represent an octal, we can begin with 0, and 0x is an hexadecimal number. Then we have floating point literals, and even in floating point, we also have an option to provide a scientific notation, so we also specified that. And then we do have character literals, and we have string literal. So string literal is something which we use quite often in a programming environment. Okay, so we have string literals. We also have Boolean literals, which is either true or false. So only these two are the elements which are part of these Boolean literals. And then we do have something called null, which is again a literal for representing a null object, a null value for the object. So this is something what you could see here. And let us quickly run this particular program. So okay, Java C. Okay, as expected, you would see the data which are there in the program, or the literals which we have defined in the program are printed. So you may be seeing that what data got printed does not have the underscore. So as I was mentioning in the theory, it is only for the developers understanding or better readability we do have that representation, but once the code is compiled, it automatically takes this particular notation where it is a normal number as far as the compiler is concerned. So in bytecode, we don't see this concept of underscore coming into picture, which is actually not required for computers to understand a number. All right, so this is something we need to also understand how it basically gets interpreted. So at the compilation time, it gets converted. So this is the internal aspects of how this actually works. Okay, so this is about literals. So now let us write another program which is a simple calculator. So to understand variables, let's go and open this particular program. So notepad.com/ I have created a Java file called simple calculator, in which I have written a simple program for doing some computations. So I have a simple calculator main method, and there are two functions or two static methods I have created. So static methods will ensure that you don't need to really go and create any instance. So creating an instance, etc., we'll talk about that in future chapters. So for now, let us just quickly execute this particular program. Or before executing, let us understand what is there inside this program. No rocket science, it's a very simple program. So here you see I have a function called add, or a method called add, static method. So you have operand 1, operand 2. So two parameters are being passed to this add method, and you compute here. So where you have specified a variable sum, which actually represents the sum of these two operands, and then what you are expected to return this value back to the calling program. So that is what we are seeing here. Similarly, I have another method called subtract. So you have the two operands or the two parameters being passed, and we are directly returning OP1 minus OP2. So what is the difference here? So I have just tried to give different ways which we can basically use. Here we have declared a variable, and then we are taking this data and then returning that. And there is another option where if it is very simple, you don't need to use this anywhere else in the program, you could also directly go ahead and return this particular value directly. So this is also another option which you can do. And now here in the main program, what I have done, so we basically create a variable called sum, and then we invoke the method and ensure that the value returned by the method is assigned to this particular variable called sum. So here you may be seeing that there is sum here in the main method as well as sum in the add method. These two are two different things because the scopes are different. So what is the difference between sum in the main method and sum in add method? So the scope is different. So we already discussed scopes in the variables chapter. So here it is inside the method. So it's a method scope of this add method, and this is not directly accessible to the main method as such. So this is something we need to keep in mind as well. So other scopes, we'll talk about it as we go in the future chapters, and look at working on those hands-on later. Okay. Next, the difference is something where I get the subtraction and then I'll get the difference, and I'm just printing this data. So let us quickly go and complete this particular compilation. So let us do Java C. So this is another way where you can directly compile, and you can go and type Java There you go. As expected, we have got the answer printed on the console. So this is what a very simple program to understand variables and how variables basically work and can be used in a Java program. So I want you to complete this particular exercise. Again, I will give the snippet that is required for this particular exercise in resources, and the resources section you would see that thing. Now I also want to basically define another additional aspect to this particular problem. So we have sum, we have difference. So two things, we have subtraction, addition and subtraction we have completed. I want you to go ahead and implement two additional methods. So you have to add multiplication method as well as division method. So two methods which we need to basically do, implement. So you add those methods. So this is an extension. So this is an action item for you people. and you have to go add the two methods to the simple calculator class and then write a program which basically tests those functionality as well. So what you can do, you can go ahead in the main method itself, you can add the other two functionalities as well, invoke the multiply method, invoke the divide method, and then you have the answer. Okay, so this is an action which I want you people to complete. So complete this hands-on and then come to the next chapter. So I see you in the next chapter.